Software Engineering Radio Episode 92, Introduction to Game Development. This is Software Engineering Radio, the podcast for professional developers, on the web at se-radio.net. SE Radio brings you relevant and detailed discussions and interviews on software engineering topics every 10 days. Thanks to our audience and the partners listed on our website for supporting the podcast. Welcome to Software Engineering Radio. This is episode 92, Introduction to Games, with Oliver Jucknath, interviewed by Arno. In this episode, we are experimenting with a message from a sponsor. In this and the next 3 episodes, we'll have a short message from OSE, a German consulting company, at the end. They're trying to find a bunch of additional consultants and co-workers. The advertisement is in German, so if you don't speak German, you probably better skip it. Otherwise, you should maybe listen. Please let us know after this and the next 2 episodes what you think about this kind of advertising at the end of the episode, whether you think that's useful, whether you think this is okay. We've had the survey where most of you said it would be okay, but just let us know what you think. Thanks, and now let's have fun with the episode.
This is Arno, and today I'm interviewing Oliver about game development. Would you like to say a few words about yourself before we dig in?
Yes, hello everybody, my name is Oliver Jucknath and I've been now programming for 30 years. And half of the time I've been writing computer games, and the other half of the time I've been writing commercial products, mostly in the enterprise area. I enjoy writing computer games very much. And I think it's one very, very special area of programming that has some traits others don't have.
Since you have experience on both sides of the fence, maybe we should start by you telling us what's special about writing computer games and how is it different from writing normal software, like business software?
Some people try to write computer games the way you write normal business software. Most times you got some Hollywood studio that has a lot of money, has some very special characters, and wants to earn some extra money by writing a computer game. Most movie adaptations of computer games are very bad because they are exactly written in the typical waterfall methods where you have some requirements up in the beginning, a lot of money, and then you end up with a very, very bad game. That's a proven method and is repeated all over again. I would like to talk about the other way of writing computer games. They start with a very, very simple requirements. Write a computer game that gives players a lot of pleasure and a long, long-lasting entertainment. Some people start with this requirement and take it further and further and develop some creative starting point idea into a very, very nice computer game. And the trick about that is you start with this very simple requirement, make something that is fun to play, and then you have to work in very, very short development cycles and to always retest what you have written to get a feedback of the beta testers that you are on the right track and that this will end up with something that is indeed fun to play.
This sounds really special. I mean, people claim they're doing agile development in all kinds of projects, but this sounds like game development is one area where it's actually done that way. How long are the increments typically if you do this agile, cycle-driven, feedback-driven kind of game development?
About 1 year for projects that don't work out. And the smaller the development cycle, the higher probability that you will get a game that's good. So in the very extreme form, you have the cycle from the developer creating a new feature to the beta tester testing it. That's within days. So you have cycles of about typically, I would say, 1 week, 2 weeks.
Wow, that's pretty short and sounds pretty cool. How much initial effort do you usually have to spend before you have the first thing you can hand over to the testers?
There are testers and testers. Some testers I can incorporate in the development very, very early. And then they can test some very spectacular triangles moving around on the screens. and test the very, very early elements of the game. But for this kind of beta testing, you need a lot of abstraction or fantasy to fill in the gaps that still exist. For public beta testing, you have to have the game nearly finished. So I would say the first 1 or 2 beta testers start more or less on the same day as the coder do. But for the big public beta testing, you have the game nearly, I would say, halfly done.
Okay, so you start out with an idea and you have beta testers in place. How about you just sort of take us through the development cycle of a game? So you start up with an idea, you want to get the game finished, and you have ideas, you've got friends who volunteer to be the beta testers. Who else do you need and how do you start?
Having a good idea is a very good starting point. Just getting together, or let's write a computer game that beats all the other stuff, is not a good starting point. You need some idea about your writing. You are writing the next generation shoot 'em up, or a third-person shooter, or whatever. This idea has to be a vision that's common to the core team. If you look at the list of persons that worked on a game, you see on modern games about 100 persons, sometimes only 50, but it's a lot of them. If you have a closer look at these teams, you always find out that there is a small core team, and that's typically less than 8 people, so 5 to 7 people, that has started with a vision of how this game should be and how this game should look like. Typically, there is one creative person, if you have good luck. Sometimes you have 2 or 3 persons drawing the game in 2 different directions, which is not a speed-up factor. So having more creative people at the very beginning is even a disadvantage. But this core team has to share a vision where they want to go. This vision is typically not what you end up in the final game, but this has to be strong enough to carry you along all these beta testers, which tell you that it doesn't work and it doesn't work again, and this doesn't work neither. You have to survive this. So you have to have one vision that gives you a goal where you want to go to. If you gather then some programmers around you, and some of the programmers typically take over the role of the very first beta testers, you should also think of the artwork in the very, very beginning, because games are the most visual things you can develop, and without any artwork it doesn't work at all. And the artwork is not just an add-on. The artwork influences the game story, whatever you have in your mind. So typically the programmers start with a set of functionality they can provide, and the art people say, okay, that's exactly what we need, and then they produce a lot of artwork that doesn't work with your library. And you have to enhance your library, and as soon as you have enhanced it enough to face what they have created the last time, they get some very, very interesting new ideas that don't work at all with your new libraries, and so the art development always pushes the program developers ahead. On the other hand, the program developers can pull the art people to produce very, very interesting and fantastic things the art people didn't think about. For this kind of work, you need very special artists. The typical artist can't do this.
Okay, so obviously you need programmers, you need a vision, you've got the testers, and you've got visual artists. Who else is on the team? I mean, there's a big gap between 5 to 8 people and 100 people. Who else is on the team?
More artists, more programmers, more beta testers. No joke. For example, the core team is responsible for the core game. That is the game executable you deliver to the customers. But in writing a computer game, you need to write a lot of more programs. You need a level editor, you need textures converters, you need a lot of external programs that can be delivered by other programming teams. And it's a good idea to split this up. As long as you can keep the development team size below, let's say, 8 people, you can live with a minimum of management overhead. And this management overhead can kill you because, yes, sometimes it doesn't work out. Sometimes it just costs a lot of time. Sometimes some idiot starts with PowerPoint presentations or Microsoft, how do you call it? This program I never use. Microsoft project, yes, thank you. When I think about game development, I don't think about this program. So you try to keep several teams, but each team a very small size. And the same goes for the artist. You have very different fields of art. For example, you need 2D art for the textures. You need 2D arts for the cover of the game. You need 3D arts that is computer generated completely. You need 3D arts that is scanned from real objects, so 3D scanners. And alone for the 3D scanners and 3D computer department, you can always hire an arbitrary number of people if they don't run out of work. So the initial stage is getting the game as far as possible with a few people that you can recognize what the game is about. And then there comes the second phase where you blow it up until it's very, very big and beautiful. And then comes the third phase where you again shut it down until you have a size that can be reasonable to finance and that can be developed in a reasonable time.
Okay, so game development goes through these phases with increased staffing, but what about the insides of the program, of a game? What's special, what's different in programming a game?
The most special thing about writing a computer game is performance does matter. If I write a program for a very big company, a web application, 300-layer program, and the program doesn't perform very well, as long as I have it scalable, people can just add hardware. And most time it's cheaper to add hardware than to optimize the program. For computer games, it's the opposite way around. For example, if you write for a console, you have a very limited computing power compared to current computers, at least. You have a limited given availability of the hardware power for triangle calculations and other stuffs for computer graphics. So you are not working time boxed or money boxed. You're working boxed by the console capabilities. This is one of the last areas where assembler program still is alive. For example, the computer graphics shaders are written assembler, or if you have an Intel CPU, you can do a lot of stuff with the SMD extensions, all in assembler. So this is still an area where assembler can matter. And because this is the last area where performance really does matter, you tend to find a lot of people that are performance nerds or performance affine in this area. So one of the biggest problems is to shut down these people when the game is fast enough. I have had one friend, okay, I may think I can quote him by name, Mike Lammerts, who has in a very long time ago written a delay loop. Then he has optimized the delay loop to be faster. And this is the kind of work that is sometimes not helpful. And yes, so this is some drive you get there. This is something where you can get a lot of fun out of this. But I always propose first to let run your performance optimizer and to find out where the performance loopholes are and so on. But then you have all the right in the world to spend hours and days writing and rewriting 10 lines of assembler code. And this is something I miss in the other areas.
It sounds like computer gaming is one of the last areas where the lonely hacking hero still has a right to live.
There's another area in the demo scene where computer programmers try to write as much graphical wow in only 10 kilobytes of codes or something like that. And I would say the computer graphics in the demo scene are very impressive, but there's always trouble to make money out of these demos. As you can say that the computer writing area is the commercial part of the demo scene.
So obviously performance is a big issue. How do you go about having this performance?
First of all, you need to find out where your performance bottlenecks are. And yes, this can be very hard because, for example, if you're running on a console game, you get limited real-time support. It's really hard work to get out where your time is running up. And sometimes you have an additional fun because you have a multi-CPU systems, for example, the cell CPUs or something like that. And they are really, really hard to debug. And especially if something goes wrong 1,000 times but fails one time and produces a jitter in the game, you have to find this jitter. My best or worst bugs, depending on the view, are those bugs that introduce a small jitter about every 3 minutes. Good luck hunting.
So this is sort of the debugging approach. Are there design approaches that you can take sort of to have fluent movement and to deal with a wider range of different equipment to make use of fast hardware if you without overloading weaker hardware?
Yes, in the good old time you need only a double buffer display to make a fluent game. Today it's much more complicated. One of the biggest challenges right now are the level of detail systems. We got very early a level of detail for computer graphics. So a monster that's far away only gets 3 triangles. If it's up front to you, you get 3 million triangles for that. This is more or less known how this works. The next challenge at the level of detail thing is to give level of details for behavior. So monsters that's far away, I got only 1 nanoseconds per monster to calculate its behavior for this frame. So I need some kind of heuristic systems that give me an approximation for the behavior of a herd with very, very few computer time. So level of details at very different level of abstractions is very, very hard to achieve, and this is a challenge. The other challenge we right now face is a technical challenge of multiprocessor systems. These are not very well understood yet. For example, the behavior of a monster is quite hard to distribute on a lot of systems or a lot of CPUs without running in deadlocks or kind of that. And once again, this is very hard to debug.
When you're talking about problems with multiprocessor systems, this sounds like multi-threading is used a lot. Is that true, and why are there so many threads in game development?
Right now, quite the opposite is true. Very, very few games can make use of more than 1 thread at a time. And most games or most gamers have machines that has 1 fast CPU, and you don't get much of a quad CPU machine right now as a gamer. So this is a challenge. Most computer studios or game studios are right now working on making their libraries multi-threading capable and to use the power of something like cell CPU systems or anything like that.
Okay, you were just now talking about the behavior of a monster. What is a typical representation of a monster or of the world at large in a game, and of the behavior of things, of the look of games, of the constellations, whatever? Are there recurring patterns of how they are represented?
I don't think we have the time to go down into the lowest levels of this, but yes, there are things that reoccur. For example, you got always a separation between the background, static content that changes very, very slowly, and they get the fast changing content. Let's call that the monsters. A very interesting thing in the interaction of the monsters with each other. For example, a very simple question is, how can you find the next monster you can shoot at? Yes, you can optimize yourself to death to solve this question. The more interesting is if you have different level of details. For example, a monster that is on a lower level of detail because it's far away to interact with a monster that is on a higher level of detail and that has a completely different behavior. For example, imagine a swarm of birds that crosses some level of detail threshold and doesn't have a migration process of going from one level of detail to the other level of detail. So another thing that's very interesting is the physical simulation of the world, because most games are involving some kind of violence, and this violence is only fun if you can see the effects of this violence. And yes, the most interesting thing is to blow something up, to destroy something or something like that. To do it in a special way or in a fascinating way, you have to simulate physics. And once again, if it's up to front to you, it's very hard work, it's a lot of computing time. So you have, again, level of details that you must handle. The most challenging problem there is collision detection. That's always a question. For example, if you shoot at somebody, how do you, in the computer world, find out whether you hit or not? One simple approach is implement ray tracing. So the simplest thing is, if you want to shoot at somebody, send a ray into this direction. Once you get the ray tracing up and running, you get a lot of additional functionalities. For example, you can send rays to detect the behavior of your underground. The simplest thing is send rays just down and see how the ground is, the state of the ground. Ray tracing can substitute true collision detection in a lot of cases. For example, we don't have any well-working wrestling simulation, because if two bodies touch each other, you have to detect where and how, and it's very, very hard to simulate that in with high enough speed.
How do you go about simulating behavior that makes monsters look intelligent? I mean, this sounds like artificial intelligence to me, sort of. I don't know if this is actually what's happened, but how do you go about making monsters appear as if they behave naturally or decide how they behave? Looks quite complex, quite natural to me much of the time, but I imagine it must be sort of simple, because otherwise the computing power wouldn't be enough. How do you go about that?
The first step is you watch players playing games. If you can reach the complexity of a player steering a monster, I can be happy. So the first thing is, if you watch players, what do they do? The patterns are simple. They tend to stay hidden and snipe at you, or some players just go ahead and want to have a maximum of fun. So just watching players, you can extract some very, very interesting patterns. And yes, once you got the pattern, to implement the pattern, yes, that's a question of how much performance you got. And sometimes simple questions like, give me my left neighbor, can cost you a lot of computational power. So sometimes you have to scale the behavior down to something that is manageable. But the first step is start looking at players. Another good source is look at animals. Yes, typical animals have, every animal has a typical hunting behavior. And you can get a lot of ideas just at looking at animals in a zoo, where they move around or something like that. Another thing is, what's very fascinating is herd behavior. So if you have a lot of monsters, and with rising computing power we get more and more monsters, the interaction of the herds inside the herd are very important, and there's a whole lot of theory about these things.
Let's go into some more detail there. How do you simulate a herd of buffalo stampeding?
First of all, each animal in the herd has to know its surrounding animals. The first thing is you have to implement a set of rules and then weight this rule. For example, one rule is don't hit the cow running ahead of me. The other thing is, if I'm hit by another cow in my back, I run faster. These rules are very, very simple, all of them. The hard thing is to arrange these rules to make something that works. For example, if if the herd hits an obstacle. That's a very, very fine art, and I don't think there are cookbook recipes for this, how to do this. That's one of the fun things about writing computer games. On some parts, you're just cutting edge. If you don't do something that's not very well known, you're doing something wrong. Then you are doing it too simple, too easy. Just make it more realistic, make it more complex to get a challenge out of this.
So you basically model the behavior by having a list of sort of simple behavioral rules, and then you look at the results, and if you like them, it's okay. Otherwise, you sort of try to fine-tune the rules, but still it remains a simple set of rules to which you add something or remove something from it, and then behavior emerges?
Yes, that's the hard way, and I would say, as far as I know, that's the typical way the commercial programs do this. But just to give you a new idea, one way to solve this problem is genetics programming. If you interpret these set of rules as a DNA string, then you can create new behaviors quite easily by recombining them. That's not that hard as it sounds right now. Just take two bunches of monsters and let they hit each other. Those who wins got a higher ranking in the gene pool, and after you've done this sometimes, let's say you start with a gene pool of 10 DNA strings, after you've done it about, let's say, 30 kills, then you choose the 3 best of this pool and recombine them. The only thing to be able to recombine is you need to start at a point where each rule sequence makes some kind of sense. Otherwise, the genetic engineering doesn't work and you don't get off. But there are some ideas in the genetic engineering programming area where you can really steal from and get these problems solved in real time. The good thing about that approach is you get some kind of artificial stupidity built in. The thing is, to build the perfect killer monster is not very hard. It just points at your head, shoots, you're dead. So it's more interesting to get something that has more complexity, even some faults to it, only if it has some interesting behavior or behavior you can look at and you accept as realistic. So this genetic approach, I've tried it sometime, gives you some behavior that looks lifelike, even if it's not perfect.
How do you go about writing a language that has recombinable blocks, where a combination of different blocks makes sense? I mean, if you just recombine the elements of a C program in a random fashion, you practically never get a compilable program. So how do you go about writing a program that can be genetically recombined?
That's always, if you are now talking about deeply aspects of the genetic programming, always the trouble. Find a DNA representation that makes sense if you cut it in half and recombine it. By the way, in nature, this also doesn't work very often, but nature has the advantage of trying it again and again, some billion times per second. But with our computer power, we can get quite near to this. So you're not always that hard bound to this, that a recombination of 2 programs yields another. You can save a lot of time if you don't just take 2 C programs, cut them in half and recombine them. This doesn't make fun. I propose take a rule-based system, where you got a set of rules with a lot of parameters. These are very, very kind to this kind of approach, and you can recombine 2 different sets of good building blocks to get a better monster. The theory about genetic programming is that by arbitrarily cutting the DNA strings, you find good building blocks and they are propagated. And so if you got a set of, say, about 100 parameters that control your monsters, then cutting these 100 parameters, adding some radioactivity by randomizing some values, works very, very well.
I see, that makes a lot of sense. To give us some idea about the level of complexity of the game, how many monsters are there typically at the same time for which the behavior must be tracked by the game in real time?
Right now, this is reversed the other way around. How many monsters can I render in correct time? I would say most games, typically games, have about 30, 40, 100 monsters. But I expect this number to rise rapidly to at least 1,000 monsters or something like that, that can be simulated in a realistic way. Because one problem you get with complex games is you go somewhere, do some demolition, affect the monster that live there, go away, come back, and they are more or less reset to the original state. So we need to increase the number of monsters only to get a better and realistic world behavior.
So now we have individual monsters, 30 or 40 of them now, 1,000 in the future, but individual monsters do not make complete missions, levels, whatever. How do you combine them? How do you make levels fun to play?
There are 2 basic approaches. The one is the control freak that places every single monster and turns it into the right direction and to have complete control about the game that he's writing. For example, Doom 3 was a game where every single monster was placed in a perfect way. These games are fun to play. They have very, very nice special effects and a very good level design. The trouble is the costs are very, very high for this approach. So you get either very, very expensive games or very small games. And one of the disadvantages of Doom 3 was once you played it, you were finished with this game. There was nothing interesting happening right now then. The other approach is that you create worlds, virtual worlds where the player has some task to do and you don't control each feature. you need a lot of more beta testing, because sometimes, for example, if you place two different kinds of monsters near to each other, they start to fight with each other and the gamer has just to walk through. So you need more beta testing, but you get much more richer levels that are much more complicated. But just placing monsters together doesn't make a level. Every good game design got riddles and lots of riddles inside. And the question is, how do you create riddles? I myself have found a very strange answer to this. I've studied computer science, and then there's a branch on the computational complexity where you rank problems in different kinds of how much computational time you need to perform that, to calculate that. And one of the most interesting problems are the NP-complete problems. I don't think I can go up into very deep details, but there are a lot of problems that are guessed to need more than polynomial time, a lot of time, short, to compute, but we are not very sure about that. It's still open question whether you can compute them in polynomial time or not. This class of computer games, this class of problems, sorry, not yet computer games. This class of problems has one very, very interesting property for computer developers. Humans are quite good at approaching a perfect solution. For example, one problem is the traveling salesman, where a traveler has to visit a list of given points in the shortest possible time. Most humans are very good at doing an intuitive guess at that. And there's a whole class of about 100 or more documented problems, and you can take these elemental atomic problems and convert them into computer challenges. There are a lot of problems that are abstract, you can't use, but at least half of them can be used to create problems that are not easy to solve, but where humans are good at getting an approximation. This is some work to do, but this is one of the interesting problems, to get a problem or a task for the gamer that is hard, but not too hard to solve.
So how would you incorporate a traveling salesman problem in a computer game?
Easy, give the player a ticking time bomb in the middle, you have 30 seconds, and you need 3 keys to disarm this time bomb.
Okay, I see that. So far we've been talking about single-player games on a console or on a personal computer, but network games, multiplayer games have becoming more and more popular. What's different with them?
A lot. There are several levels of multiplayer games. One level is, that's quite old, you have some people working together, playing together, which is quite hard work sometimes, playing together on a local network and where you have a high bandwidth and communication is easy. These games are more and more replaced with centralized servers that can handle very huge amounts of players. And for example, World of Warcraft has attracted millions of players right now. And there are a lot of technical challenges at that. For example, the simple problem of collision detection in a multi-user environment is very, very hard to solve, because if you have one simple cycle where every player has to do what he wants to do, send it to the server emulates the world and sends back the images to each client, you get a very, very slow response time. So to increase the response time, or at least the illusion of a fast response time, you have to emulate the world in parallel on the client computer and on the server computer. And if this emulation is flawed by, for example, different behaviors or different runtimes of the data, these models of the different worlds differ from each other. So the main server has to sometimes send the correct image of what is true to each other player. This needs a very clever algorithm how to synchronize the client's view or the client computer's view of the world with a true view that has the central server. This is a very fascinating thing to work at. The more fascinating thing is to test it. If you want to test a simple single computer user game, you can give it to a single beta tester. But if you want to test whether a server can survive 10,000 users, you need 10,000 users, because these 10,000 users try things you can't imagine up front. For example, there was a competition how many people fit into a single room in World of Warcraft. yes, this is something the developers don't think of, that about 100,000 people try to get into the same room. Yes, so if you want to make beta testing for multiplayer games, you need a lot of players.
Let's take a closer look at this getting out of sync between the server and the clients. Why does that happen? I mean, it's the same program code on the server and on the clients. Why can't they get out of sync?
Imagine that there are two players, both firing ahead at a swarm of Klingons starships shooting at you. If the Klingon starships are a herd, as we described it earlier with the cow herd, a single shot at a single ship can change the behavior of the entire herd, and herds are chaotic systems, so even the slightest difference in a time when I shot the first monster produces a completely different outcome, whether, for example, the complete herd turns tail and runs away or continues to attack.
Okay, I understand that the herd behavior is chaotic, but why should there even be this initial slight difference in state that can then, due to the chaotic nature, escalate? What is the initial cause? Why do they get out of sync in the first place?
Imagine a herd of Klingon starships approaches two players. Each player client has a model of this world on his own computer. And if I do something, if I, for example, shoot at this first approaching starship, this starship will react inside my own simulation. And then this event will be propagated to the other computer. So imagine two players shooting at the first starship approaching. On my computer, I shoot at this ship from the left side, so this starship turns away. On the other computer, the player starts at the right side, so the starship turns to the other direction away. And the complete herd follows this first behavior. So, on my computer, the first starship turned left. On the computer of my friend, it's turned right. On the server in the middle, nothing at all yet happened, because the transmissions are quite slow. Then I propagate my state of the world to the central server, and I told him, okay, I hit the first starship and it turned left. The server says, good for you, but I've heard from your friend's client computer that he also shot at the first starship and it turned right. Then you get to have some kind of solution. So either the starships just jump around on the screen, very, very bad solution, or you have some very, very smart algorithm that is able to deliver very small parts of my reality and then for very, very fast to the server, that the time from start of different developments to the resolution is very short. You can't prohibit this completely. It happens always. But the question is, how nice can you get out of this bad solution? For example, you can morph this starship around, or you can just let it explode. Always a good solution in game design. If something is nasty, if something can be not handled in an effective way, just let it explode and all your problems are gone. This may be a difference towards commercial programming, where blowing up some kind of data store or something like that is not appropriate.
So it basically boils down to, while bandwidth in network communication is limited, you cannot have a single server in the center, so you need to sort of do incremental synchronization and then blow things up to get in sync again if they got too far out of sync. Okay, so now we took a closer look at the problems and the differences, the specialities of implementing games. But how do you a game?
I understand you mean user interface design. Yes, the user interface design of games is very unique because gamers respond very badly to bad user interface design. So, for example, the typical design of some word processors would never survive the next LAN party if they were used in a computer game. If you have a user interface that hinders you in the slightest way, people get really, really annoyed and don't like your game. Then you lose. So you have to optimize your user interface in such a fashion that the player, after playing the game for, let's say, about 5 minutes, no longer recognizes he needs an external user interface and is in the game itself. If this takes too long, or if it's always again interrupted, this inside game feeling, by thinking, okay, how can I do this again, you lose. So you have a very, very strong urge to interface this, to optimize this computer interface as far as possible. That's a much higher urge than in most other applications I know. Another thing is, if you design a user interface for a computer game, you can design it a new way. If you want to write a new interface for a word processor, you better stick to how things have been done for years and years and years again, because your secretary wants to have their word processors work like they did yesterday. If you are a big enough company, you may break this every 10 years or so. But as a game designer, you have a lot of freedom to create new user interfaces and new ways of interacting. As long as the gamers can learn them in-game, they are perfect. So if you have some kind of new idea how to open a window, some special 3D effects, let there be a billion answers running on your screen and painting each a pixel or something like that, you are free to do this. Writing a user interface for a Word application is quite boring. You get the menus right and you are done. But computer games are maybe like some military equipment, very, very driven hard to get a perfect user interface, and then they are willing to throw overboard all existing guidelines if you get some idea how to kill faster.
I like this parallel between writing computer games and having military equipment. Both are about blowing things up. Having this requirement for sort of perfect user interfaces. In many games you have some sort of interface for allowing people to customize the user interface. How far does that go towards, sharing the effort of creating the perfect user interface? To what degree can you integrate third parties or even the users themselves?
There are left-handed people and right-handed people, and you should consider this, but this is as far as it goes. The art of building a good user interface is a very hard art. If I can't do it myself, I don't have the right to say, okay, I can't do this, let the customer do it themselves. Building a good user interface takes hours and hours just configuring and tuning the parameters to the right values. This is no task I can upload on the user. So I think it's a responsibility of every game creator, really every game creator, to deliver a good user interface.
Okay, point taken. It's your responsibility. So let's imagine I want to start my own game company. I want to write a game and sell it. Maybe this is what some of our listeners are asking themselves now. It sounds like fun. You can be the hero, hard coding, have all the creative freedom. So let's say I've got a garage that I currently don't need and I want to start my own gaming company. I have the idea for a great game. How do I go about actually getting started?
Bring in a lot of money. Yes, that's the central point of writing games. You can either do it in a professional way, then you go to a company, then you get a lot of tasks, and then you will find some people using Microsoft Project and planning what you are doing. I think you can do this. This is a very serious job, how to do this. And the other way, the garage way, is you need some kind of daytime job where you can get all your money. And then, as an alternative to playing World of Warcraft, you create a new game in your free time. And this is a slower approach. You still need a lot of people working together, at least in the starting core team. But this frees you of the commercial pressure in the very first step. Starting with the second step, making things bigger, you need a lot of money, and then the whole stuff of venture capital and so on starts. But I really propose start it on a small scale. If you can't make a game to be fun in a small scale, you can make it as colorful and painted with as much art as you want. It won't make much more fun. So start with a small team with a vision how to develop it, and stay off the big money until you have an idea that makes fun to play.
Okay, so it's partly good news, partly bad news. You can sort of get a game that's fun, and if you can't do that, you might want to get in venture capital to finance the graphics. But, well, what I take from what you're saying is there is no simple way to create a big-scale, real, commercial-grade computer game. Well, bad luck. But anyway, is there any final words you'd like to share with our listeners?
Yes, there are. Just do it. If you are a gamer that likes playing computer games and you have always dreamed of writing your own computer game, do it. Many of you will fail, many of you will learn a lot while they fail, many of you will have a lot of fun while they fail, but some of you will succeed, and you will find writing computer games is a very challenging job and has a lot of benefits.
Well, thank you very much.
You're welcome.
As mentioned at the beginning, here is a message from our sponsor.
Hallo,
Hier sind Bernd Österreich.
und Christian Weiß von der Firma OSE aus Hamburg.
Wir suchen zur Festanstellung J2E-Entwickler mit exzellenten Architektur- und Java-Erfahrungen.
Als Coach und Trainer bringst du unseren Kunden bei, systematisch bessere Software zu entwickeln.
Warum arbeitest du hier?
Vielleicht, weil OSE ein bisschen anders ist, als sonst Firmen sind. Die Mentalität ist anders, das Grundgefühl ist ein anderes. Man hat sehr viele Freiheiten. Ich habe das Gefühl, man wächst so ein bisschen über sich hinaus.
Die Idee, ein bisschen wegzukommen von der reinen Technik und dem reinen selber Programmieren hin zu mehr Leuten auch was mitgeben, Leuten ein bisschen eben was beibringen.
Man kann spannende Sachen machen. Das ist wirklich so. Man hat Freiheit, was man machen möchte.
Ja, weil es ein abwechslungsreicher Job ist. Man kommt sehr viele spannende Projekte rein.
Ich finde das sehr schön, dass ich hier die Freiheit habe, viele interessante Dinge zu tun, die kurzweilig sind, da mit Kunden zu arbeiten, mit Menschen zu arbeiten, auch wirklich eine gewisse Art an Freiheit, mir selber bestimmen zu können, welche Richtung ich mich entwickeln möchte, wo ich hingehen möchte. Das ist für mich persönlich sehr wichtig.
Weil mir die Arbeit einfach mit Menschen Spaß macht, und das mache ich sehr häufig halt, dass ich probiere, das Wissen, was ich habe, weiter zu vermitteln, dabei selber dann aber auch lerne, weil halt OSE für mich auch ein Arbeitgeber ist, der es mir ermöglicht, mich selber weiterzuentwickeln, nicht nur jetzt auf so einer technischen Wissensbasis, sondern eigentlich gerade auch persönlich. Das sind schon Sachen, die eine sehr große Nachhaltigkeit haben.
Ich arbeite hier, weil ich sehr viele interessante Anregungen hier bekomme, sehr vielfältiger Art. Gerade der Austausch mit vielen sehr kompetenten Kollegen, das macht sehr viel Spaß.
Genau das, man hat halt eben sehr unterschiedliche Themen, die man bearbeiten kann, auch sehr unterschiedliche Aktivitäten, also gerade das Coach-Mitarbeiten ist durchaus auch möglich. Trainings haben auch relativ hohen Anteil, aber es ist halt eben auch nicht nur Training, und das ist so der Hauptgrund, warum ich hier bin.
Wir freuen uns auf deine Bewerbung.
Schau mal rein unter www.ose.de
Mit Doppel-O.
oder schaue im Sing unter Christian Weiß.
Mit Doppel-S.
Thanks for listening to Software Engineering Radio. If you want more information about the podcast and all the other episodes, visit our website at se-radio.net. If you want to support us, you can donate to the SE Radio team via the website, or you can advertise for SE Radio, for example, by clicking on the Dig, Reddit, Delicious and Slashdot buttons. To contact the team, please send email to team@seradio.net, or if it's specific to an episode, please use the comments facility on the website so other people can read and react to your comments. This episode of Software Engineering Radio, as well as all other episodes, are licensed under a Creative Commons license. Please see the website for details. Thanks to Charlie Crow and the Podsafe Music Network for the music used in this show. The song is called Vegas Hard Rock Shuffle.